Okay, hello everyone. It's very nice to see you all. And I'm William Koch. And today I will share you some experience on Apache projects in modern data stacks. Then I introduce myself first. I'm William Koch. I'm Apache Software Foundation member, and also Apache IPMC member, and also PMC of Apache DolphinScheduler and a mentor of Apache SeaTunnel. And many people knows ClickHouse, and actually I'm the founder of ClickHouse China community, and also I'm the track chair of workflow and data governance of Apache Kong Asia. I used to work at Analysis and Lenovo, and also work as Teradata, IBM, CSCC, and Wanda. And I have more 20 years experience of big data technology and data management. So today I'd like to share some experience on modern data stack. Actually, modern data stack rebuild enterprise data ecosystem. There are many new modern data engine, not only Hadoop, but also like a Snowflake, Databricks, and also many other data lake and other some engines in recent days. And also we have some real-time data engines like Flink, like Spark Streaming, and like Amazon Kinesis. And also we have some cloud to support our data process. And also we have some, we call them modern data analytics. There's many BI tools now. And now we have many modern data applications like a citizen data scientist or enterprise data portal or AI argument data analytics or real-time security or democratized ASI. Then how to use these tools to support the enterprise to build a very good big data platform. Then there's a new word we call data ops. Data ops includes data orchestration and the data integration and the data transformation and also data governance. We can see a lot of tools like Airflow or DolphinScheduler or iByte, Fivetran, SeaTunnel, or DBT or Calibra BigEye in data ops. So here is a very big picture of all the things. Let me try to show you. Yeah, so here you can see the, So here is the Apache projects in modern data stack and the data ops in enterprise. Now we have a two parts of two kinds of data. Now, one is we call the streaming data. The other we call the batch data. The streaming data can generate from like a sensor data or IoT devices or weblogs or social media or ERP or CRM systems. And we can use, we call it a SeaTunnel connector to connect the IoT devices to the data consumers. And also we have a SeaTunnel agent to collect the data from weblogs or from social media. And also SeaTunnel has some, we call it SeaTunnel CDC. That means SeaTunnel change data capture to capture the data from a database, from a bin log. And then you can use SeaTunnel engine or Flink or Spark to do the filter, load, normalize, and sync the data to your target. Sometimes the target will be the Kafka, and then you can use a SeaTunnel or other tools to sync the Kafka to the ClickHouse, to the Redshift, or to the Elasticsearch. Then you can use the superset or Kibana to do the visualization. And also you can use the SeaTunnel engine just from sync the data to the alert systems or to your IoTDB or other NoSQL database. And when you do the streaming data, we call the real-time data process. And some people want to do the real data process, also make a copy to the batch data process. Then you can use SeaTunnel to do the copy your data stream to your Hoodie or to your Hive. Then you can, one way to use the data to do the real-time data warehouse. The other you can, and also you can use the SeaTunnel to load the data to your batch data systems. And the other way we call it batch data. Batch data will be generated from unstructured data, or like a file or message queue, or relational data, or cloud data, or some NoSQL data, big data systems. And you can use SeaTunnel to collect the data together. And then SeaTunnel can sync the data to HDFS or S3 for further usage. Or you can load the data to the Hive or to Apache Hoodie, to the data lake, and to do more transformation. And sometimes people will use both data lake and data warehouse together. Then you can sync the data from Hive, Hoodie to Snowflake, or to Teradata, something like that. Or you can just use the SeaTunnel directly, load the data from the unstructured data to the data warehouse without data lake. And you can see there's there's many things like traffic light. And actually, if you want to do like the whole system work correctly, you have to have a one we call the data job orchestration. Here I just call it DolphinScheduler. It's just like a traffic light in your whole data systems, and it can not only orchestrate batch data workflow, just like ETL jobs, but also it can handle the data stream workflow, like streaming data, Flink, Spark streaming, and Kinesis, something like that. And also it can orchestrate the ML ops workflow. It can orchestrate TensorFlow, MLflow, Amazon SageMaker, PyTorch, and then DolphinScheduler can orchestrate both streaming data, batch data, and MLOps workflow together. Then you can do make a workflow like that. You can collect the data from sensor data and use the data stream to load the data to your data lake, and then you can use the batch data job to do the preparation of the data, and then you can use the machine learning data job to training the data and deploy. And this is what DolphinScheduler can do. And also, DolphinScheduler can handle the SeaTunnel, and a SeaTunnel can synchronize and feedback the data from your data lake or your streaming. It can just feedback the data to your Oracle SAP or to your Cloud Web3, S3 or Amazon Redshift, or you can just use SeaTunnel to synchronize the data back to your relational or social media or Workday or SaaS. Then you can see here is a very big picture that there are many Apache projects in modern data stacks and data hubs in your enterprise. Now today I want to introduce two of them. One is SeaTunnel, Apache SeaTunnel to synchronize data and to connect data together. The other I want to introduce you is DolphinScheduler, is to do the data jobs orchestration, to do the to do the orchestrate your batch job flow or data stream flow or MLOps flow. So first, I'd like to introduce Apache SeaTunnel. Actually, Apache SeaTunnel is a project that do the data synchronization, and it's just synchronize the data from your source to your destinations. But it can offers you various of connectors. For example, it support MySQL, Postgres, and TidyB, Elasticsearch, and also you can load the data to your TidyB, to Hoodie, or to Iceberg, or to other things. And also, SeaTunnel can support we call Spark engine, Flink engine, or SeaTunnel engine itself. Now SeaTunnel will have more than 50 connectors to support your synchronized from different database. And now SeaTunnel has many use cases. I think there are two main user scenarios. One is high volume and high frequency for your big data platform. For example, for Bilibili, Bilibili has more than 100 terabytes data with hundreds of millions of data records to do the extract and the load from other system to their data warehouse, or from the data warehouse to the other system. So Bilibili is using SeaTunnel to solve the problem of we call the bulk load. For example, I don't know whether you use ClickHouse in your data platform. ClickHouse is running very fast, but insert something to ClickHouse is very slow. And how to improve the efficiency of load the data to the ClickHouse? Actually, SeaTunnel is a solution. SeaTunnel can generate the ClickHouse, we call ClickHouse file directly, and then SeaTunnel can copy the ClickHouse to the ClickHouse system, and then to solve the problem of insert data to ClickHouse one by one. It just can do the we call the bulk load to your ClickHouse system. So Bilibili is one of a kind of user, and also SeaTunnel can bulk load other data to other systems like HBase or other data systems. And the other user scenario is we call it real-time data synchronization with many data sources. The typical user is yp.com, and SeaTunnel just solved the data synchronization problem with MySQL, log files, Presto, Kafka, Spike, ClickHouse, and Hoodie. And then VIP.com can synchronize the data from different data sources. And also there's many other users like Didi, just Shopee, and Oppo, Tunar, and ThyssenKrupp, and Weibo. And this is some use case about the SeaTunnel open source. And what's the SeaTunnel design goals? I just heard from PMC discuss about all things. Actually, SeaTunnel is try to build easy to use and distributed and scalable data integration platform, and support ultra large data with high throughput and high or low latency. So without SeaTunnel, we often met some problems, like there are many data sources if you want to synchronize data from one data source to the other, because each enterprise will have a lot of systems, not only operational data, but also in big data platform like a Hoodie or Hive, ClickHouse, Presto, or Kafka, and Elasticsearch, and something like that. So you have to build your connector yourself. Not every system support JDBC, and not and JDBC is not very quite efficiency to solve the data, load data or extract the data. So the first problem SeaTunnel solved is to load and sync data from many data sources. And the other, when you synchronize data, you will often meet the scenario that one is called a batch data load. That means you have a lot of data and you have to load the data one time, but a large volume. And the other we call it CDC, the change data capture. That means when you you do the real-time data processing, then you have to write two programs to solve the data, to solve this kind of problem, to sync data. You have to write one program to solve the problem of a batch data processing, and the other is real-time data processing about to synchronize data. So SeaTunnel can let you just write the program once, then it can support not only batch data load, but also support CDC or real-time data synchronization. So this the other problem we met, and also now the data technology stack is very complex. If you use if you design your program, you have to learn Scala from a Spark, or you have to know Flink SQL, or you use other technologies. And then if you use SeaTunnel, we will offer you we call it a tag script, and also we will support, we call it user interface in the future. Then you can just drag and drop to create your data synchronized job in the future. And then SeaTunnel can let you easy to synchronize data from different databases. And also, we will meet some problems about data quality and monitoring, because if you use other Apache projects or other platform, you cannot ensure the data consistency. Also, if there are some problems, you cannot roll back to the breakpoint and continue the execution. So SeaTunnel can support that, and then can ensure your data quality. And also, we have some problem difficult to manage and maintain your jobs, because like what I said, offline synchronization and real-time synchronization are often managed separately, and the difficult to maintain. And also, we call the data cutting is performed manually. That means if you want to synchronize data from one database to the other, perhaps you have to use a batch load at the beginning, and then use CDC at the second stage. But when you switch from a batch load to your CDC to a real-time load to your real-time synchronization, it's very difficult. So SeaTunnel can support you with that. Without it can automatically switch from the batch load to your to the CDC mode. So this is some good point from SeaTunnel. And also SeaTunnel has many new connectors. Now we have more than 50 connectors, and I think it's nearly doubled from the year from the beginning of this year. And I think it will be more than 150 in the next year. So the connector and the community are very active. So you can now you can see there's many sources SeaTunnel can support, like Hive or Fishu or InfluxDB or Iceberg or MongoDB connectors like ClickHouse, Doris or Kudu or TiDB, and also we will use some transformation. We support some transformation tools like JSON replacement, SQL, and UDF. And also, their SeaTunnel support multi-engine support, and it support engine like a Flink, Spark, and also SeaTunnel has its own engine, and I think it will be released in the next month. And SeaTunnel engine has a more efficiency than Spark and Flink when you just do the synchronize data and not to transform the data. So if you are interested, you can join the Slack channel and have a discussion in the future. So in summary, SeaTunnel has many new advantage. Like SeaTunnel is a high throughput to support source, transform, sync, parallelization to improve your throughput performance, and also it has a low latency feature, and it's based on real-time processing and macro batch processing provided by SeaTunnel engine. And also, if you use SeaTunnel, you can ensure your data. We call it exactly once because it has a distributed snapshot algorithm to support exactly once. So if you're interested about SeaTunnel, you can visit the Apache website, which is SeaTunnel.apache.org, or you can go to the GitHub, or you can join the Slack, or you can see some tweeters on SeaTunnel. So this is the first project I want to introduce to you. And the other project, we called it the Apache DolphinScheduler. This is orchestration tools. And actually, there's many other tools to do the orchestration. And in old days, actually, we can use cron tab in Linux to do the similar things, but it cannot support triggering dependency. And then there are Azkaban and Airflow to support the schedulers. But these tools are not visualization design. And so you have to code to code with Python or Java to create a workflow job. And also Azkaban Airflow are not we call the multi-master and a multi-worker. So it cannot support a large volume of tasks very easily. And it's lack of a multi-cloud data management. And then Apache DolphinScheduler is a new kind of data orchestration tools. You can make your task scheduling with visualization, and it can support various of task categories. And also it is designed, we call it decentralized design, enable high stability and availability. It's a multi-master and a multi-worker. And also we notice that users can use DolphinScheduler to support millions of tasks and millions of billions of data running in their data platform. And DolphinScheduler has more than 1,000 active users and more than 350 contributors, and it has many users. So DolphinScheduler, the main feature of DolphinScheduler, you can see you can just drag and drop to create what you see and what you get workflow without code. You can just drag a shell or Amazon EMR or SeaTunnel or DataX to your job, and then you can to drag to drop to connect them together. Then you can see there is a workflow from a shell 1 to SQL code 1. And then we call the DAG map, and the DAG map can be very big, and also this DAG map can be used by other, we call the sub workflow. Then this DAG map can be a function used by other workflow. So it's very easy to use. And the DolphinScheduler has a high performance, high stability with multi worker and multi-masters. So you'll see in DolphinScheduler, there will be many master servers and many worker servers. And every master server has their own job or own task to do. It's not designed like we call the master slave or active standby mode. It's just use a hash map to hash function to let every task and every workflow to work in different master servers. And now DolphinScheduler is trusted by many industry leaders like Tencent, IBM, Cisco, China Unicom, and many users all over the world. And I think there are three main typical user scenarios in DolphinScheduler. One we call the high performance and high volume task scheduling. The typical user is China Unicom, because China Unicom has more than 1 million tasks in their scheduling systems, and because China Unicom has to orchestrate the Hive SQL and the SQL in China, all of the China, including 31 provinces and many cities. So there are few systems can support that kind of that big large numbers of workflow. So China Unicom chose DolphinScheduler to handle the problem with the large of volume of tasks. So then the similar users are Cisco and Alibaba Cloud and Ping An in China. This is the one scenario we use DolphinScheduler. The other is we call the global cloud deployments with ease of use of data consumers. The typical user is Shane. Shane originally used Airflow to schedule their global task, but Airflow is a centralized design and is lack of a visualization. And also it cannot support Kubernetes very well. So Shane to choose to migrate from Airflow to DolphinScheduler. Shane has about more than 50,000 tasks, and they found that Airflow cannot support that big large of tasks. Then they just migrate from Airflow to DolphinScheduler, and they just deploy DolphinScheduler on Kubernetes directly, and then use the feature of DolphinScheduler decentralization to ensure the stability. And because it's very easy to use, then many data scientists and data analysts to use DolphinScheduler to orchestrate their jobs, and they are not developer background, then it's very easy to use for DolphinScheduler. And a similar user of VMware and McDonald's. And the third scenario about DolphinScheduler is we call it ML orchestration. It's LegiFM and 360 company, and they use DolphinScheduler as we call it a data scientist platform orchestration, because DolphinScheduler has a very good DAG orchestration engine, and it can just make machine learning progress in a DAG, and also you can reuse this machine learning process in other machine learning process. So it's very easy to use, and also it's low code IDE. So you also can connect the process from a data preparation to your machine learning process. So it's very easy to use for data scientists. So Liji and 360 company use DolphinScheduler as machine learning orchestration. And now I want to introduce some new feature about DolphinScheduler in 3.10. And in 2.0, DolphinScheduler has many features like simple and what you see, what you get workflow, and high reliability, and also rich workflow functions in the cloud native and extensible. But there's more new features in 3.10. The first feature is we call machine learning orchestration. Then you can do the data preparation and MLOps in one orchestration platform. Now it supports MLflow, SageMaker, DBC, Jupyter, PyTorch, and then we will support Kubeflow, TensorFlow, BenoML in the end of this year. And the second feature we call the data stream support. That means you can not only support batch data orchestration, but also you can use DolphinScheduler to handle the Flink and the Spark streaming in one orchestration platform. And also we can manage the data stream in DolphinScheduler. And the third feature is now DolphinScheduler, if you are a Python guy, then you can use Python or YAML to generate DolphinScheduler workflow directly. And that means you can do code review and deployment more easily. And also 3.10 support Kubernetes more easily. So the first feature is we call it PY DolphinScheduler. PY DolphinScheduler is the Python API for Apache DolphinScheduler. Then you can define your workflow by Python code, just like in Airflow. So you can easily to use Python to generate your workflow very easily. Or you can use a YAML file to create your workflow very easily. If you want to use code or want to use some script to create a workflow, not a drag and drop to create a workflow. And then you can manage your workflow instance in DolphinScheduler, and you can just use the runtime mode to handle the orchestration workflow mode. And the other feature we call ML orchestration. ML orchestration is to let data scientists to do more, have more efficiency for the machine learning lifecycle, and also let machine learning system to connect with other systems like data preparation system or data processing systems. And now have some new features like DolphinScheduler can orchestrate user existing machine learning tasks, and also out-of-box orchestrates to mainstream of MLOps projects. And then you can provide some preset algorithm capabilities through open source machine learning projects, and connect the data learning platform and big data platform together. Then you can see here is an example of ML orchestration. You can just use a shell or EMR to do the data preparation. Then you can use like a PyTorch or SageMaker to do the machine learning jobs. And it can very easily to create new jobs with drag and drop or Python or YAML file. And then you can see machine learning workflow can just can handle in DolphinScheduler to do the data preparation, training, and deployment. And also you can use a DolphinScheduler to handle the workflow between like a Spark and a SageMaker. SageMaker is just like a task in DolphinScheduler. And also DolphinScheduler just can help the data scientist from the data management to the model management. And DolphinScheduler now we support data management tools like DBC, SageMaker, and the feature store tools like OpenMDB, SageMaker, and the model training like Python, Jupyter, MLflow, PyTorch, SageMaker, and also it can deploy your model with Shell, Python, MLflow, SageMaker, and also do the model management. And I will introduce some task plugin shortly. Then you can use the ML orchestration tools very well. The first is the Jupyter task plugin. The scenario is to schedule the execution machine learning notebooks like model training. You just you can type some parameters and to create a task to do these kind of things, and also to schedule the execution data analysis and data visualization notebooks, and run the notebooks with different parameters. And then you can create your Jupyter task plugin very easily in DolphinScheduler to do this. And here is to do the machine learning process. And also DolphinScheduler support ML task plugin. You can run the process algorithm and then run custom ML projects and they deploy the MLflow model. And also for MLDB, you can to use DolphinScheduler for the offline feature extraction and online feature extraction, and also with the let them offline and online consistent together to use for the OpenMLDB. And for DVC task, we support upload the data and record the version, and also support the download the specific data. And then we support large file version management based on Git repository. So you can use the DVC task to do the data version management very easily. That means you can prepare your data and then use DVC tasks to handle the version of the data. And also we support Amazon SageMaker. We can schedule the execution of a SageMaker pipeline and connect the task like upstream big data analytics or some downstream tasks. Then you can use SageMaker and Spark and Shell and Python and even PyTorch together in DolphinScheduler. So for PyTorch, we can support migrate the machine learning project to the DolphinScheduler and run a Git-based machine learning projects, and also can run TensorFlow and other machine learning projects. So now we currently support MLflow, Amazon SageMaker, OpenMDB, DVC, Jupyter, and PyTorch. And in the future, we will support TensorFlow, BentoML, Kubeflow, and Core. So if you're interested, you can join our Slack channel to discuss the future about it. So here is some of the results about DolphinScheduler. The website is dolphinscheduler.apache.org. And also you can join the Slack channel or the Twitter, or if you're Chinese, you can join the WeChat. And here are some videos on this link. And so in summary, we just introduced the Apache projects in modern data stacks and data ops in enterprise. There are many projects here. And I introduced two of them, SeaTunnel and DolphinScheduler. So here is my my contact. You can add me in LinkedIn, or you can contact me in Twitter. So I think that's all for my talk. And thank you for listening. And if are there any questions about my speech?